Okay, we're on number five, which is protection of information assets. And this is very crucial for the defense of organizations, our respective organizations. And so they just want us to have knowledge about, information security, and that is what this section is for. So the other time we look at various ways of connectivity, and various devices you will see in a local area network, in a wide area network. And we stopped on multiplexers. And I said that day, all right? So you have like 4 or 5 signals to move from one point to the other, right? You are going to have a lot of overhead if you are transmitting them one by one. So what they do with multiplexer is that it's like a compressor. It compresses the multiple signals into one. So you can see this 4 by 1 multiplexer, all right? So you have four signals. It has compresses into one, so it is easier, all right? You will have less overhead moving one output compared to just moving 4 or 5 different traffic. All right. So when it gets to the destination point, then you are going to have another device called demultiplexer. Demultiplexer. So to now break. So it's going to be the reversal of multiplexers. Right. Break the traffic again into uh, is constituent traffic. All right, so it's a way of improving the efficiency in the wide area network transmission. All right, so we have what we call wide area network technologies. There are so many technologies you can use to connect, uh, the wide multiple points together. The last time I talked about point to point, right? So maybe you have an office, head office, and they have only a branch for now, head office and a single branch. So we don't need to stress ourselves. We can easily use point to point because it's just one link we need, all right, to connect the head office and that branch, and that's it. All right. But this will not work when you now have a second branch. You have a third branch, you have a fourth branch, fifth branch. Right. So like in the banking environment where they probably have some traditional banks, for example, they have hundreds of branches. So you know that this will not work. All right. So some people came up with X.25. All right. They came up with X.25, which is also a wide area network. All right. So you can have multiple points. So what you will need is X.25 cloud. All right. So apart from these two locations, you can have another one here. You can have another one here. You can have another one here. Another one here. All right. The connectivity is the X.25 cloud, which actually is just to interconnect all the locations. We also have another wide area network called frame relay. All right. So also that one too, you have multiple locations. You are going to have a frame relay cloud. All right, which all of them can connect with, and through the frame relay cloud, they can actually share transmissions uh, across the various geographical zones. We also have ATF, asynchronous transfer mode. All right, so that was also developed as a wide area technology, wide area network technology, which is meant, so it's also a cloud. You can see it's also a cloud. All right, so the different locations are connected by ATM cloud. One thing I have of note that I think I also need to mention here, normal packets, the message, I talk about message switching. The message is actually broken down into packets. Then they are now transmitted in form of packets. When it gets to the destination, they bundle them together back to message using the sequence number of each of the packets. They assemble them together. Now, an average packet has variable size. All right. Normally, normal packets has variable size. The size are not the same. All right. In fact, there's one attack that is called teardrop attack. Teardrop attack. So it's used to bring down a particular host in a network. You know, the researchers have discovered that if a message, I mean, a packet has size that is more than, I think, about 56,300 and something bytes. All right, 56,000 bytes. All right, if they send a message, you know, a packet that is more than 56,000 bytes, the machine, that machine is going to collapse. Denial of service. They call it, teardrop attack. So that is to prove that indeed the size of typical packets, it always differ. But in ATM, in asynchronous transfer mode, the packet size is always fixed. That is what distinguishes ATM cloud to any other cloud, frame relay, X.25, and the rest of them. The packets here are always fixed in size. They call it cells, right? The packet here, we call it cells. So asynchronous transfer mode is another technology that has been widely adopted, right, for connecting points in a wide area network. So I'm talking about point to point, talking about X.25, talking about frame relay, talking about, all right, I didn't talk about ISDN. All right, integrated service digital network is the one technology they use to transmit videos, voice, data, video. So it is very suitable. So you can actually expect that, in telecommunication industry, this one technology will have a lot of applications, all right? A lot of use cases. So you can use it to transmit voice, data, video conveniently across a wide area network. ISDN, please take note of that. I'm talking about ATM, all right? I mentioned all right, they make use of cell, right? Make use of cell. So the packets are of fixed size, right? Instead of the normal packets that you normally have of variable sizes. All right, you also have a multi-protocol label switching, MPLS, all right, which is also another wide area network technology that can be used to transmit in a wide area network. So there are many options. All right, there are some one terminologies you can be hearing: unicast. What is unicast? All right, that means in a wide area network, one sender is sending to only one receiver. That's unicast. You have broadcast, which is more common, right? One sender is sending to multiple receiver. Like what we are doing now is broadcast. If I speak, every one of you is hearing me. If any one of you speak, all of us will hear you at the same time. All right, so that is broadcast. All right, we have multicast. Multiple sender are sending to multiple receivers at the same time. Multiple sender are sending to multiple receiver. So that's what's called multicast. All right, digital subscriber line is another wide technology, which is used to send, like internet directly to homes. All right, I'm already seeing that technology being deployed in Abuja in some estates now. So you have internet directly from the internet service provider directly to the homes of the individual high bandwidth internet. All right. Then of course you have VPN, which we are all familiar with. All right, especially when they ban Twitter. All right, what's an example of multicast? I'm actually multicast, maybe Well, sometimes I think television station, there are some television stations that have radio station. All right. So I'm looking at that as maybe an example of multicast. So you have an organization, they are broadcasting from the television station and the radio station at the same time. All right. So people are receiving the signals on TV, people are receiving the signal on their radio, within their frequency. All right, that is the only okay. There are other ones. Well, sure, I think there are other ones also. What about World Cup? All right, what about World Cup? It's just a single match, all right? But you have different television stations across the whole world, right? I think that's also another good example. All these soccer games, all right, where multiple television stations are giving broadcasting rights, all right, based on your registration and payment. Okay, so you have so you have Nigeria NTA or whichever one AIT, whichever can pay, all right, and you can. So if you have DSTV, you can watch the same match or on the Nigerian channel. If they pay, you can watch it also on maybe on other foreign channels, DSTV channels, and the rest of it. So the same match actually, but you have different broadcasters because different stations were given rights. All right. But those different stations too, they are also broadcasting to millions of people. So I think that's a very good example where you have a multicast scenario, multiple senders, multiple receivers. So the television industry is actually a very good example where you have a lot of this wide area network. All right, then you have VPN, which we all will have used at one point or the other. Maybe you want to access Twitter during the plan, or you want to work remotely. All right, most organizations that does remote working they use VPN. All right, because of the security. All right, so it basically is actually for remote login. You are actually you have your head office in Lagos, somebody is offsite in Kafacha, right? And the person wants to log in securely across the internet, you use a VPN. Okay, then we have TCP/IP terminologies. You have what we call uniform resource locator. What is uniform resource locator? It's actually web address. We call it web address www.yahoo.com, www.twitter.com. All right, is we call it web address, but the technical name is actually uniform resource locator. All right, we have what we call CGI, Common Gateway Interface. All right, it's used. You have two type of websites. You have a website that is called static website. You have another website that is called dynamic website. A static website like a corporate organization's website. You just go there for information, right? About us, our management, our services, our products, contact us, right? So most of the time you just go there to view. That's a static website. Then you have some dynamic websites like Facebook, for example, is dynamic. You can create web pages, right? There are some what about even Google form is dynamic, right? You can write a quiz, an online quiz, then you submit your answer, then it gives you a feedback immediately, whether you are passed or whether you are failed, the ones to get correct, the ones to get wrong. That's a very dynamic website. So Common Gateway Interface, CGI scripts are used to enable that communication between the user and the web server in a dynamic website. All right, that is basically what a CGI scripts what they are used for. Now, I remember, okay, let me not mention it. All right, it's actually of they can ask you in the exam. All right, one key thing they normally ask about this CGI script is the fact that there are many of them that are already written. You have CGI scripts that you can find online. So when you are developing a website, you may not want to start writing your own CGI scripts. All right. So you can just go online or you go to a relay chat or internet relay chat or maybe a developers forum, and you can easily use one. But the risk there is that you don't know whether they are malware embedded in the CGI script that you are not the one that writes it. This is one area they often test, all right, on CGI scripts. Then we are all familiar with cookie, all right. Virtually every website we go to today is telling us that they have cookie. Some of them will not even tell you. All right, the idea of the cookie is basically to drop something on your system so that they can monitor your interests on their websites. And the idea is that they'll be able to serve you better. They'll be able to know aspects of their websites that are of interest to you, aspects of their services that are most of interest to you. They can give you specialized services. That is the original idea behind cookie, but of course, with time it was abused. All right, so people now use it to spy, all right, on web users. So it's a lot of risk these days because you don't know it can be used to breach privacy. All right. So then you have applets. Applets is actually, just like you say, piglets. What's a piglet? Small pig. What's eaglets? Small eagle. So what's applets? Small applications. All right. I was surprised the day I discovered that. All right. So applets is actually small applications. All right. So when you are on the net, you have what we call a user side, a client side, you have a server side of browsing, server side, right? Then you have a client side. So the client side is right somebody in front of is it in front or behind now of the web browser. You are the one typing www.whatever.com, all right? So that's server side. So your experience basically on that server side. You want to, the original website design, started from HTML, hypertext markup language, which is basically you can't develop a very beautiful website, all right, that will have all the GUI, graphical user interface, this UI UX, user experience, all right, user interface, user experience. You can't have a very good UI UX experience with HTML, all right, because it's more or less like it just provides structure to the website. That's why you see sometimes when Gmail is slow or Yahoo is slow, they will give you option to use the basic, all right, version, which is just HTML, before they start having add-ons, all right, to the HTML to make it more user friendly. All right. So basically, applets are meant to improve your user experience on the application side. All right. I mean, on the client side, when you are using a website or you're using a web application. So applets are meant to improve, all right, the user experience on the client side. All right. But one risk it applets to just like in the CGI script is that often the web developers don't write their own applets, so they just use already made applets, and that also has its own risk because you don't know if they are malware in those applets. Okay. Then you have servlets. So you know what servlets mean by now. So it means they are little servers. So the servlets are meant to enhance the server side, all right, experience of browsing, of using a web application, which will be invisible, all right, to the user, all right. So of course, when you say www.yahoo.com, so you are on the client side, you're the one typing yahoo.com. What the system is expected to do is to contact through the web browser. Web browser will send a message, a request to the web, to the host, to that server hosting that yahoo.com. All right. So, and there are a lot of things involved with that, all right? The speed of response, security, and so on and so forth. So, servlets are meant to enhance the operations of the web server, all right, to improve the server side experience. So, you want to, instead of, for example, now we can create like a cache. All right. So if you are somebody that is always going to yahoo.com, is instead of you troubling the server all the time, they can create like a, like a catch whereby all the information that you normally need is stored temporarily, right? Not even on the web browser or on the web server now. But so you can easily get those information faster without having to disturb, all right? So that's what servlets can do. So they can be like a servant to the web server. So some of the information you most likely need most often need to discover can actually be on the servlets. All right. So sometimes like that. So you don't. So your response is faster, and even the operations of the server itself, web server itself, is enhanced because it has less pressure. The other pressures have been taken off the main web server by the servlets. All right. So that is what a servlet is meant for. You use to improve the server side experience. So it stays in memory and can fulfill multiple requests, thereby saving server execution time and speeding up your request. That's how this web is this website is very fast. It's very fast. Sometimes you didn't even reach the web server. It's the servlets that are responding to your requests, and especially the basic requests. All right. So the risk too is also like the risk of the what is it called? The risk of the applets. They can be breached. All right, they can be because some of them too are also pre-written, right? So people just developers just use them. All right. So if thorough checks are not done, you can introduce a servlet in the environment that is already compromised. All right, I believe all those are clear. Then you have bookmark, right? We all do use, right? So you have a website that you like that is informative, all right? So you can bookmark it like a marker, okay? So that it will be easier for you to be able to, visit that website again without you forgetting the address. All right. So network administration and control, it has become more, it has become easier now to manage a network with all these tools. All right. So anybody with an average network experience can actually be able to monitor what is going on, all right, with SIM tools, security, event, information management tools, network monitoring tools, simple network monitoring, and so on. So you need to be able to monitor what is happening on the network, who logged in, who logged out, all right, what protocols are in use, because some protocols may be banned in the organization, all right, what locations are people logging in from. It could be of interest to you. There are some environments that you can only log in from the office. So if you are not checking and maybe the office is in maybe we'll say two, then you see somebody logging in from Ibadan, and it should be of worry to you, all right, in such a situation. All right. You want to also check what is called throughput. You can see I highlighted it in red. All right. It used to be of serious interest to Isaka. I don't know about now. All right. But those days, you always ask a lot of questions about throughput. Throughput is simply work done by time. That's what I wrote here. Work done by the device in the network per unit of time, maybe per second or per minute. All right. So security incident discover failure conditions, all right, backup, backup of data being processed in the network, and so making changes for scalability as the network usage grows. That's capacity management. All right. Latency is also another network technology, which is a delay. All right. You send a packet from one point to the other. How long will it take for it to get to move from the source to destination? All right. So that is also very important because if the latency is very high, then that means network will be very slow, and that would not be acceptable. All right, I've talked about throughput already. So we need response time reports, right? Response time reports so that we know how fast requests are being executed in the network. We need downtime reports so that we'll be able to know, which of each part of the network is which devices are failing, all right, in the network. That is also very important, all right. So generally, you need to switch to a more dependable transmission link. All right. We said that dedicated lines are always more reliable than share lines, but it's more expensive. All right. Install backup power supplies. All right. Very important, especially in a third world like Nigeria. Improve access security. All right. Closely monitor utilization. All right. I'm talking about capacity management, right? So monitor bandwidth usage, monitor storage usage, monitor license usage, and so on. All right, so use online monitors as much as possible so that you'll be able to know what is happening in the system. Network monitors provide a real-time display of network nodes, which node? Network node is the machine, all right? The machines in the network, devices in the network is what we call network nodes, all right? Network protocol analyzers are also very important. I think I mentioned it that you should Google I think they call it common ports. All right, common ports, PORT. All right. Common ports. So you have many of these protocols. They have common port number. Common port number. So you have HTTP, right? That's the for internet, for browsing. It uses port 80, right? So they use it in firewall administration. So if you block port 80, it means that nobody will be able to browse. All right. So you have POP, post service protocol, which is used to receive email, uses port 110. All right. SMTP uses port 25, I think. FTP, file transfer protocol, which is used to download, uses port 21, I think, right? 21, and so on. So you have they call it common port number, very important for administrators, right? Firewall administrators, networks administrators, so that they'll be able to know which ports to close, which ports they can allow to be open, and so on. All right, so this is very important in security. So you need to know the protocol um, that is uh, uh, that is being used in the network. You need to know the ports that are open. There are tools you can use to do that. All right. So which protocol is in use? Type of packet flowing. All right. Traffic volume analysis very important. This can alert you if you are going to have a denial of service attack. The traffic is just surging, you have to investigate it. Where is the surge coming from? All right, hardware errors, all right, percentage of bandwidth use, problems, possible solutions, can get all this from network management tools. You also have a protocol called SNMP, Simple Network Management Protocol. They use it in cyber cafes, all right? All right, all those cyber cafe administrators, they do use it to monitor, right, what is going on, the cafe attendants, what sites they are going to, what they are downloading, and so on. So the network administrator can sit in his chair and actually monitor everything that people are doing in the cafe. Then we need help desk reports, right, to be able to know the queries that people are asking, the kind of help, right, they're asking for, the kind of problems users are encountering, all right. So you can prepare that help desk reports on a weekly basis, on a monthly basis, on a quarterly basis. It also help us guide IT service management. All right, on-demand computing is a new computing model where it is pay as you go. Instead of having a fixed head office, fixed data center, whether you are working or not, does not matter. The cost is there. But now we are moving to on-demand cloud computing, basically, where if we are not working, we shut down, and we are not incurring costs. It's only when we are working that we start incurring costs. So we have software as a service. All right. One of the earliest software as a service is Yahoo, right? Yahoo.com, Gmail. All right. You are not paying, right? Nobody is paying for Gmail. You don't pay anything for Gmail that you are using. You're not paying anything for the Yahoo you are using. You don't even know where their servers are. You don't know where the hardware is. You don't know where the software. You just log in. All right. So it has been with us since. But now they have extended it. Software as a service. So look at Microsoft 365. All right. You don't need to have any server infrastructure, all right, to use Office 365. That's software as a service. All right. Then you have infrastructure as a service. Your data center is in the cloud. All right. Then you have platform as a service for developers. So the development environment is with the vendor. It's managed by the vendor. We'll come back to. So the idea of on-demand computing, for example, cloud, is that your cost of operation drops drastically. It drops. Don't need to be buying, hardware up and down. And even the distraction of, servicing, maintenance, all those are taken away and they are managed by the service provider. All right, network infrastructure security. Network control functions should be performed by individuals possessing adequate training and experience. So you have to send your network people to, specialist trainings, CCNA, CCMP, CCIE, right, CAC, right, network security training, all right, as much as possible. They have to be trained and be retrained. Network control functions should be separated and the duty should be rotated on. So as much as possible, don't give one staff the entire control over the network. All right, as much as possible, if the resources are there, separate the roles as much as possible. All right, network control software must restrict operator access. So use access control software. All right, access rights management software to be able to limit what people can do. All right, then of course there must be audit trail. There must be audit trail. All right, audit trail of all operational activities. Then of course the audit trail will be useless if we do not periodically review it. Right, the audit trail should be periodically reviewed by operations management. All right. Look at the case of this young lady that said she was the one that got the highest score in Nigeria, even though it was late to rest, this week. But it was highly emotional. All right, I was following it. All right, and I didn't particularly, I didn't support what she did, but I just still didn't particularly, agree with the way Jam just went all out. All right, so but they have to defend themselves. But what I'm trying to say, what I saw that I am impressed with is the log. I was even checking the report this morning. All right, they have all our interactions with Champ server were logged, and that was what actually emboldened Jam to say yes, this result is fake, and they were able to print the log. All right, they were able to print the log, they were able to show us this is when she did this is when she sent in this particular report, this is when she make an inquiry. So there's case closed. Nobody can argue against it. All right. So audit trail should be periodically reviewed by operations management to detect unauthorized network operations activities. Network operation standards and protocols should be documented, all right, and made up. So standard operating procedures, all right, that's what that is talking about. It's also a requirement in ISO 27001. You need to have standard operating procedures for your network people so that if anybody does anything outside the requirements, outside what is stated in standard operating procedure, we can use that as a basis, all right, to query that person. Network access should be monitored. all right, and review. So we need to have a technology, a tool that we are using to monitor what people are doing on the network. Analysis should be performed to ensure workload balance. So I've talked about load balancers. So we need to have load balancers in the network. We need to be able to also ensure that we are monitoring to see if a particular node, a particular machine, all right, a particular subnet is being overwhelmed. You should be able to notice that on time. Then there should be terminal identification file. What do you mean? Every terminal, every computer, every laptop, every tablet that is sending messages across the network, you must be able to track it. All right. Whether you are using the MAC address of the machine or you are using the IP address, but we must be able to have a way to track that this message came from this particular machine at this particular date. So all these are very important to know what is happening on the network. Then as much as possible, when you are sending sensitive information, use encryption. As much as possible, use encryption. Restrictions should be placed on remote printing. All right, so be careful. Like somebody was telling us some time ago, a bank that has an office in Nigeria, an office in Ghana. So somebody printed from Ghana, in Ghana office, right? Printed something in Ghana office, and that document was picked in the Lagos branch, the Lagos office, their printer. So you can see something is wrong with the network connection. It's already a wide area network. Worry about if that information is something that, all right, should not be seen by somebody outside the Ghana office. You can see the risk. So restrictions should be placed on remote printing as much as possible. Device admin. What do you mean by admin in information security? All right. Number one, change default passwords. All right, change default password. If you go to defaultpassword.com, there's a website like that, defaultpassword.com. All right, virtually all the devices you could think of, their default password is on that website. So if it is a company that is using maybe a printer or a Cisco router, all right, that they didn't change their default password. Anybody that is aware of that website can just go in there and check the default password, and you will log in successfully. All right. So that's device admin. But now part of device admin is also disabling services you don't use. Please take note of that. All right, because services you don't use, what is the implication? Is increasing your attack surface. That's what they call it in ethical hacking. So it's like you are just increasing the opportunity for you to be attacked. All right. So that's another element of device admin. Another element of device admin is patching. Right. The vendor has released a patch, apply it as soon as possible so that you can address any vulnerability that has been discovered. All right. Perform risk assessment regularly, all right, for your network environment. Perform risk assessment regularly. Then do security awareness and training for employees, all right, as often as possible. All right. A company in America called Targets, you can check it. All right, the Targets breach. All right, Target, just like what is it called? Just like all these retail supermarkets like ShopRite, Nigeria. Imagine if ShopRite is hacked. None of us, right, could be at risk. You have used your ATM card to buy something one time or the other. All right. So imagine if if the repository is not secured, it's not encrypted, right? Then that could be a problem. So the breach target, how did they breach targets? They breach targets through their vendor. All right. And how did they breach their vendor? Phishing email. Somebody in the vendor organization click on a link, and that was it. So that is why we need to do continuous security awareness training, all right, for our people. Then of course firewalls, right? As much as possible implement firewalls, right? And it's not just enough to implement firewalls, you have to have rules. For example, you can have a very secure firewall security configuration. Somebody go and change it. I've seen it happen. All right, somebody go and change it. All right, for one reason or the other. There was a case that happened in in FCT in Abuja, right? Somebody in IT has the firewall administration to relax the rules because it was doing something and the firewall was blocking it. All right, and they don't have a change management policy that will have required them to get approval before that is done. So the firewall administrator just relaxed the firewall rules, and that time that the firewall rules were relaxed, a ransomware just entered their network and locked their key servers. So it's not just enough to say we have firewall, our rules are good and the rest. What about firewall change management? All right. Some people don't even have the rule at all. They don't have any documented rules on firewall. We'll talk about firewall as we continue. All right. You have IDS, intrusion detection standard systems. All right. In case your firewall fail, you should have an alert mechanism. That's what IDS is, to alert you that something that is suspicious activity is going on. All right. Sometimes we have what we call a false alarm, right? False alarm. It's also called a false positive. False alarm. But it's better you have false alarm when you are checking it than there was an attack. You're not even one. You're not in the know. All right. Remote access for coordinating and centrally controlling dial-up access on the internet via corporate resources. All right. That remote access should only be enabled as when needed. Right. You can't just allow without business justification. Then, of course, you need to have an incident response plan, incident response team. Very important, so that any incident going on can easily tackle them. I've talked about configuration management, all right? When I was talking about firewall changes. So once a configuration of a router, of a firewall, of a switch is set, all right, that configuration should be documented. Anybody that will change it should get approval. All right, we should have encryption on the devices. All right, we should be able to control what is happening on everybody's desktop once you're in the network. Right, the security administrator or the network administrator should have the facility to know what is on what there are technologies for that, to be able to know what is on your desktop. All right, then monitoring, of course, like I said, is very important. All right. So let's talk about firewall. All right. If you have questions, all right. If you have questions, please, I want you to post your questions. If you have questions, please post your questions. So what is a firewall? All right. In the like in the some hundreds, like 300, 400, 500 years ago, like the British, what they normally do is they have what they call a moat to protect castles. All right, so you have a castle here, then the castle will be surrounded by a moat. A moat is simply like a river. So they have a way of flooding the the moat to surround the castle to form a circumference around the castle where the king or the noble person is staying. All right. But once it's flooded, there will be like a bridge, a movable bridge that you can use to cross, all right, from the castle across the moat to the other side. But when there is an aggression, maybe some people are trying to attack, all right. So what they simply do is they flood the moat, all right. Then they remove the bridge because the bridge has to be removable. So they remove the bridge. So the moment they remove the bridge, and of course, those days, it's basically arrow and sword. So the distance between the moat and the castle will be outside arrow range. So you can't use arrow, and you can't also cross unless you want to swim. And it's a very, it's more or less like a river. It's very flooded. So more or less that castle become, unreachable, all right, to the threat. That's one way, all right, they protect castles those days. All right. Another way they protect uh castles those days is to create a fire, a wall of fire. All right. That's actually where we got firewalls from. So they create a wall of fire, all right, between the threat and the castle. So unless you are fireproof, which most people are not anyway. So that's when you will jump into that fire. So fire quote, they also use fire to defend castles or very important building. All right, so that's where we got the name firewall from. All right, so you create a wall of fire. So what is simply does, so the job of a firewall is very similar to what bouncers do. All right, it's very similar to what bouncers do in a club. When you go to a club, right, maybe they can size the person up, right? Okay, maybe based on your dressing. I say, no, 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 you can't, right? The bouncer can. Or they can say, okay, what do you want to buy? There are some environment is what to buy that will determine whether you can stay in the club or not. So at some clubs, they say, I don't know how far that's true, that you have to spend maybe up to almost 1 million, all right, before can be given access. So if you don't spend up to that, okay, good luck. What am I trying to say? There are rules that the bouncers would have been pre-given, right? So if the guest or the patron does not meet this particular checklist, all right, throw him out, all right, and that's what happens in clubs. So once the person, all right, the so-called patron, all right, does not meet a rule, all right, they say, sorry, you can't have access. And if the guy insists, then you now know the meaning of bouncer, all right? They will now demonstrate the bouncer for him. So the guy will find himself, all right, in the air, being bounced, all right? So that's what the bouncer does. That's basically what the firewall does. So you have to give the rule, all right, to the firewall, all right? You have to give the rule to the firewall, right? To tell the firewall these are words. So you can see this is the outside word. This is a screening router, a type of firewall. This is a bestial host, a more robust firewall than a screening router. All right. So the traffic has to go through the screening router, meet the first barrier. If it passes, all right, some of the traffic will be dropped here. Some of the messages will be dropped, cancelled out by the screening router. All right, then it goes through the basting host, which is more advanced firewall. All right, so more packets will be dropped here. Anyone that survive can now have access to the private network. So that is basically how a firewall operates. Then we have what we call firewall policy. All right, where is that? Yes, firewall policies. Basically, there are two policies generally of setting up a firewall. You have what we call accept all except policy. What does that mean? Every traffic is acceptable except certain traffic we have discovered that is malicious to our environment. Every traffic can go through, but this one, all right? So it's not like somebody saying, like they told us that the devil is black, right? The devil is black, all right? Or you see somebody wearing black, that this person must be dangerous, all right? So maybe you now told your bouncers, okay, please, this club, anybody that is wearing black, all right, that person could be dangerous. Don't allow that person to have access to the club. Now, that is accept or accept. So what they are doing now is that so the bouncer Once you wear white or black, they allow you. Red or black, they allow you. White or blue, they allow you. So like that. So, but the problem with that is that you're assuming that a criminal will only wear black and black, which is not true. So there was somebody that was wearing white on white, who is probably an assassin. All right, the buzzer will allow him. All right, and will face the consequences later. So you're assuming that you know all the traffic that could be injurious. So accept all except is not safe. All right. The only good thing about it is that somebody, a legitimate traffic will not be blocked unnecessarily. A legitimate traffic will not be blocked unnecessarily. All right. I remember some time ago when one of Don Jassie's artists was the one that have to rescue Dr. Sid, all right, from police. All right, because policemen were thinking he was a criminal, so they stopped him and they were harassing him. All right, and he's one of the new Don Justice artists. I have to don't know. This is Dr. Sid now. That sang says no. So because so that is somebody that is not a criminal but is being stopped. All right. So, but that will not happen if you are using accept all except. Or because everyone will go to only the bad guys, supposedly the ones will be stopped. All right, but it has been deemed as it's not a good way to set up your firewall. The best way is deny all, everybody be blocked except the ones we know. All right, except the one we know. Like somebody said, I was reading on Ireland this week that somebody paid 2.5 million naira, was crying on the social media that she paid 2.5 million naira to agents, visa travel agents. All right, and of course the money money was lost. All right, and somebody was advising that why we that he cannot pay 2.5 million naira to somebody he does not know at a personal level. All right, that is that is denial all except. So everybody is blocked except these people that you know. But the problem with that is that some traffic that are legitimate will still be blocked because we are here to confirm that they are friendly traffic. But it's better. You only lose maybe some time. Maybe a department will complain that no, we are not, we can't work. All right. Then that will be a delay, compared to a traffic that is dangerous being allowed through the network. So deny all except block all traffic except number one, number two, number three, number four, number five, which are the five traffic lines, all right, or protocols we are using in this organization. So if there's a need to add to that, it is called white listing. To that white list, all right, the list of the angelic, if you will, all right, the angelic traffic, we can add to that list later. All right. So this is deemed to be the best. Deny all except instead of using accept all except. Please, if it's not clear, please let me know. This is very fundamental to information security, very fundamental to firewall administration. All right. So it's what we accept that we will enable. All right, is what we accept that we enable. Every other traffic is blocked. All right, you just uncheck basically the traffic that or the services that you know you need. If there's a need to add more to the whitelist, we'll do that later. But for now, block everything apart from the services you need in the office. All right, types of firewall. We have packet filtering firewall. All right, don't forget your OSI layer, which we talked about last week, OSI layer. All right, so we said there is application layer, right? There are seven. There is presentation layer, layer six. We said there is session layer, layer five. There is transport layer, layer four. Then there is network layer, layer three. Now, routing, interconnecting, start from layer three. So the packet filtering routers actually are on layer 3. So the lowest router, the lowest firewall you can ever find is operating at layer 3 of the OSI. And what they do is very simple. It's simply like a policeman, right, that stops you on the road and say, where are you coming from? He tells him, tell him, where are you going? You tell him. And he's okay with where you are coming from and where you are going. Says, go. He didn't search you. He will not bother searching you at all. All right? That is what packet filtering firewall does. They ask the question, where is this packet coming from? Is it allowable? Where is it going? Is it allowable? If they are satisfied with the two questions, they allow the packets to go. If they are not satisfied with the two questions, they block it. It's just like a young man bringing a lady to the house, right? And say that this is the woman I want to marry. And the dad says, say, the young lady, where are you from? And the lady says, I am maybe from Ijebu, right? And the father said, what? Ijebu people? No, 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 we don't marry Ijebu in our family. Right? No, it is, yeah, of course, unfortunately, it still happens. All right, it still happens in our society. All right. So you discriminate against people based on where they came from. You have not sat down with the person, you have not talked about the person with the person, you have not gotten to know the real person. So you just hear this is where he or she came from, you block your line. It happens. Firewall does the same thing. Packet filter firewall does the same thing. A very good example, if you want to go, you just see one money making idea on YouTube. There is one website, they pay you for, reviewing, maybe for, they pay you for reviewing maybe adverts or reviewing, writing comments on video. Believe you me, there are websites like that. All right. Then you see it on YouTube, and you see so many comments, maybe you see like 300,000 comments. Say, wow, let me try this. You go to the www whatever, and it says, sorry, your country is not allowed. Why? They have seen your IP address coming from Nigeria. They don't want to know who you are, all right? They don't want to know whether you have integrity or you don't. The moment they see that IP address is coming from Nigeria, they drop your packets. So that's packet filtering firewall basically. It's just there. Sometimes the IP, the machine you want to go, you want to have access to, you want to connect, maybe a restricted machine. All right. So maybe they are whitelisted, maybe just like 10 IP addresses that can reach that machine. So obviously, if you are not on that, your IP address is not one of those 10, automatically your system, your laptop, your phone, whatever is already blacklisted. So in that case, it's not where you are coming from actually, it's basically where you are going. So if the IP address is restricted, and your own IP address is not one of those allowed for that machine or for that device, then it's going to drop it. So that is packet filtering firewall. There are more concerns about the source IP address, right? And the destination IP address, right? So if it's not based, if it's not agree with what the way they are configured, good luck. All right. So you can see what they check basically, all right. So this client want to send message to this server, but what the system does is it checks source IP address, check destination IP address. If it's not agreeable, it drop it. But you see, the data itself is ignored. What we call the payload. So when you see a packet, when you hear packet, now packet actually has three components. When you see packets, a packet in network packets, all right, it has what we call header, all right, it has what we call payload, it has what we call footer. Now, so this payload is actually the message, is actually the data being transmitted. Right, this header contains, all right, it's like It contains source IP address. You know what source IP address is now? The IP address of the machine that is sending the message. Okay, it contains destination IP address. What is destination IP address? The IP address of where the packet is going. Okay. Then it contains what is called port number. Port number is like the number of the protocol. 80, like the example I gave, 80 for if the protocol is HTTP, right? 110 if the protocol is POP and so on. So if it is packet switching router, this is where it stops. The footer is just like a sign off, right? Just like a sign off. This is the end, right? This is the end of the packet, just like a sign off, right? So these two are actually the most important component of any packets in the network, the header and the payload. So the limitation of packet switching router is that it stops here. So if this one passes, but you know that it's possible where you are going. So it's like you just see a guy and you just say, okay, or like the example I was giving the other time, right? That the guy takes a lady to his parents, and the lady says, the father says, "Where are you from?" Right? Okay, the lady is from Ijebu. Maybe the family tree is also Ijebu. All right, so wow, that is great. You are from our place. All right, so I think I give you my blessings. Okay, it's also an Ijebu person, and that person will become and they may be the one that will scatter the whole family. All right. So source IP is good. All right. I'm just trying to contextualize the technical information. All right. So source IP is good, Ijebu. Destination IP is good, Ijebu. But the payload, the person, the character, the personality is bad. So, but if it is just packet fitting router, it will pass it. To pass it. It won't check the payload. So because it doesn't check payload, it's very fast. Right? It's very fast. It doesn't slow down operations. Right? But it can be faked, it can be deceived. Like you have IP spoofing. So like the example I gave now, the guy knows that, all right, the father doesn't like Ijebu people. And maybe the girl is Ijebu, right? But he knows the father likes maybe somebody that is from maybe from Ibadan people. Then it's bad. So the guy can tutor the girl and say, please, when you reach, don't tell my dad that you are from Ijebu. Tell him that you are from Ibadan. All right. So maybe by the time the relationship have gone so far and it's too late to do anything. That's why they will break the news. Maybe on the day of introduction. All right. So the son may try to corner like that. If he truly loves the lady. All right. Say, okay, please don't tell him that you are from. You tell him from your father. We'll manage it later. All right. It happens. If you watch all these Nollywood films, right? Even stranger things like that happen. That's spoofing. All right. So like I talk about whitelist, so you can have some IP addresses on the whitelist. So if the attacker knows how inside information, he can spoof one of the IP addresses on the whitelist. So it is the blacklisted IP address that is moving, all right, but it will deceive the firewall, all right. That's why you see now. That's why Nigerians go and use the VPN. You see not. So you are banned from using Twitter. All right, your IP address has been banned, has been blocked, but still Nigerians were still, all right, we're still browsing. Here in Nigeria, why? Spoofing. So your IP address is masked as another IP address. So there's nothing the firewall can do in a situation like that. All right, so it will pass. Another one is source routing specification. All right, so this one is done by an insider. So you know that this is the path that is the packets have to pass through to go and meet the firewall, so they will divert it. So they will divide the path of the packet so that it will not go through the, so it will circumvent the firewall. All right. You have miniature fragment attack. So they can break the packet into more sub packets. All right. Hoping that the fact that it's not a single packet, all right, it will be able to fool it will increase the chance of fooling the firewall. So that is also possible. So that's why most of the time it's not encouraged for you to use a single type of firewall. So you are going to have other type of firewall, like for example, application firewall. Application firewall is now more mature. All right, it operates at layer 7. So you can see packet switching router or packet switching firewall operates at layer 3. All right, and as you go up the OSI layer, the more the complexity, the more the maturity. So the application firewall, all right, operates at layer 7. So it can actually check the data, can actually check the payload and say, okay, what are you carrying? All right, it can actually check the payload of the packets. So unlike packet filtering router, which will only check, the source IP and destination IP, this will check the payload, what is being carried by the packets. So that makes it more effective, and that also means it is slower. All right, that makes it more, that makes it slower than the packet filtering router because it does more job. The application firewall tool can be broken down into two. You have application level firewall, you have circuit level or circuit gateway firewall. The application level firewall operates at layer 5, while circuit level firewall operates at application level operates at layer 7. All right. Circuit level firewall operates at layer 5, right? That is section layer. So you can already guess that circuit level firewall, since it's operating at layer 5, what it does is it checks sections, right? Connections, sections between 2 points, 2 networks. Is the sessions legitimate or not? It checks the legitimacy of sessions. All right. So if the sessions is deemed illegitimate, look at North Korea now, more or less isolated from the rest of the world. They don't watch all the things we take for granted in Nigeria or outside Nigeria, CNN and the rest of it. It's not allowed. They're not allowed. Their internet is more or less like intranet. All right, because if you are on internet in North Korea, you can't browse anything outside North Korea. Your internet is within so sessions between North Korea and South Korea is deemed illegitimate. All right. So circuit level firewall can look at sessions and say, okay, this is legitimate, this is illegitimate. Application level firewall can look at protocols you are using and say, no, this protocol is not allowed here. Drop it. All right, so like I said, the circuit level firewall, right, check sessions you use to determine whether they are validated or not. Then you have another firewall which is called state-free inspection. So like I said, packet routing firewall, right, operate at layer 3. Circuit level gateway, right, operate at layer 5. Application level operates at layer 7. All right, state-free inspection firewall operates through layer 3 to layer 7. Safety inspection firewall operates, it can check at layer 3, you can check at layer 4, you can check at layer 5, you can check at layer 6, you can check at layer 7. All right, you would think that because of that, it will have more acceptability. No, all right, it's too complex. So please, in the exam, always go for application level firewall, especially when it is used, all right, in combination with packet routing firewall. This is a very complex firewall, and of course, complexity is a vulnerability. All right, mistakes will be made. All right, so a safe inspection firewall can actually screen from layer 3 to layer 7, and that makes it very, very complex. Now, one of the areas that is very confusing in firewall in Cisa is what they call firewall implementation. Honestly, I didn't get it when I was writing Cisa. I didn't understand it. All right, it was after I passed Cisa and I was training Cisa that I really understood it, because you have types of firewall. So we have packet filtering, you have application, you have safety inspection. All right, then you now have firewall implementation. All right, what does that really mean? Now, if you watch soccer, all right, if you watch football, all right, in football strategy, all right, there's what they call formations in football. For example, you can have 4-4, 4-4, is it 4-4-1 now? You need 10, 4-4-2. All right, so what this means is that, all right, you're going to have 4 people at the back for defense. You're going to have 4 people playing midfield, and you have to have 2 strikers. All right, so it's the way you're going. So you have 10 players. 1 person is a goalkeeper, so that leaves you with 10. So how are you going to unleash the 10 against the competitor or the competition? So you can do 4-5-1, right? Which means you have just 1 striker. All right, you have just 1 striker. All right, maybe you can have something like 2, 4, 4. All right, that means you have 4 strikers. All right, then you have 4 people in the midfield. You have 2 people at the back. All right, like somebody like Cisa, Samson Cisa used to use 5 strikers, 5 forwards. Believe so much in attacking football. All right, very entertaining, but because they are always attacking minded, they are not defense minded, it often results into losses. All right, so this is football. The same thing is also applicable in firewall. So we have different type of firewalls we are going to use. And how are you going to arrange them? That is what we mean by firewall implementation, the arrangements. All right. So you have screen host firewall arrangements. This area is important. Screen host firewall arrangement. What does that mean? We're going to use 2 types of firewall. This is the outside world. This is the packet filtering router. This is the bastion host, most likely an application firewall. All right. So any traffic coming from outside will go through this packet filtering router first. Remember, this packet filtering router will only check source IP and destination IP. All right, so it will drop some unwanted traffic, but not all, because it didn't check the payload. All right, the rest of the traffic, whatever passes, all right, whatever passes, so survives this check, will go through the bastion host, where we can now check. All right, we'll go through the payload where we can now check the we'll go to the bastion host where we can now check the payload properly. Some packets will again be dropped. So whatever survives the second check is what goes into this network. That's screen host. The problem with screen host is that this firewall and this firewall are on the same network. Both of them are the same. So it is easy because they're on the same network. Whoever breaches that network can collapse the 2 of them. It becomes easy. So once you have breached the network from where the 2 firewalls are, all right, the 2 firewalls are at your mercy. That's the problem with screen hosts. So somebody came up with dual-owned firewall. Now, it's also the same. The structure is the same. So this is the internet. This is the packet filtering router. This is the bastion host. You can see it's almost the same arrangement, but there's a difference. The difference is that the 2 of them are on different network. Here, the 2 of them are on the same network. Here, the 2 of them are on different networks. So if you breach one, filtering will still continue to go on. So the attacker has more work to do because if you breach the first network, all right, you have to breach the firewall. That's like double work. Then you have to breach the second network before you can be able to say you want to attempt to breach the second firewall. So this is kind of it increases the workload that the attacker is going to face. So the spin-nose firewall, the dual-home firewall rather, is seen to be more secure than this screen host where they are just on the same network. All right. Then the third one, which is most reliable, is screen subnet firewall. It's also called DMZ or demilitarized zone. Demilitarized zone. Now, in this case, you don't use two firewall, you use three. So the traffic is coming from outside. It goes through the packet filtering router. All right. Whatever survives goes through the bastion hosts. All right. Then whatever survives goes through another packet filtering router before it now have access to the internal network. So you have, so this TMZ or screen subnet firewall is deemed to be more reliable than the first two. All right, so your most sensitive or critical resource, you will use TMZ to protect them, like web servers, your database server. All right, you want to hide them behind a screen subnet firewall or a demilitarized zone because of the level of checks. The other ones is just check level 1, check level 2. But this one, you have check level 1, check level 2, check level 3. So that makes it more reliable than the other two. So your most critical information resource, right, are protected with a DMZ. Please don't forget this. Firewall issues, I've talked about some of them. Firewalls can be deceived, all right? Especially if you are using just packet filtering router. Somebody can spoof your IP address on your whitelist and it will deceive the firewall. All right. I've also talked about chain management. Chain management may not be, all right, may not be mature, and that will also lead to problem. All right. So we can have a false sense of security. Firewall is not enough, all right? So that's why you need to have what we call defense in depth. So you have layers upon layers of security. All right. Firewalls can be circumvented through modems. So you have modems. Of course, we have a lot of modems in IT environments. All right. So modems can be used to dial in. Modems use phone numbers, right? So anybody that knows the phone number associated with the modem can actually dial into your network, and that traffic will not go through the firewall. So that's one way that they use to circumvent firewall. So that is also another thing that we should be concerned about. I've talked about configuration. Firewall can be misconfigured. All right. It's cool. Apart from change management, it can be wrongly set up so that it's not going to block what is expected to block. All right. So what constitutes the firewall may be misunderstood. Like we said, just having a packet routing firewall is not enough. But do not check payload, do not check protocol in use. Monitoring activities may not occur on a regular basis. So even when firewall flags some things for you to check later, you may not be checking. All right. Do we have questions? So far, so good. Questions on firewalls. Questions on firewall? All right. Please let's not forget to check those foundational material I sent earlier on networking. All right. They are also very important to give us more background information on these technologies. All right. So let's talk a little bit on encryption before we go on our on our tea break. So basically, encryption is used to hide information, right, from people that are not supposed to see that information. It's meant to address confidentiality. We all know what confidentiality is by now, right? So, like in my tribe, Yoruba, we have what we call Eno. Eno. So that Eno is like you can have a brother and a sister, they have their own language of communicating, and they will have agreed, all right, this is go, this is come, this is jump, this is run, all right. So they will have agreed among themselves. So that way they can be in public. We used to do it when we were in primary school a lot. All right, I think even in secondary school. So we can be talking, all right, in public, and it's only two of us or three of us that will know what we are communicating. All right, unless we tell you that this is actually what this means. I'm sure is prevalent in virtually all the tribes in Nigeria. That is actually what encryption is all about. All right, so it's a way to hide. So we do what we call, we convert, all right, we convert what we call plain text, all right, we convert it to ciphertext, all right, plain text to ciphertext, all right, using, an encryption algorithm. So there's always a program, all right, that is used. Mathematics, this is mathematics. So mathematics plus programming is what they use to create this encryption algorithm. So if you look at the field of encryption, you see a lot of mathematicians there, mathematicians and programmers. Then you have what we call the encryption key. All right, encryption algorithm, encryption key. So this encryption key is like similar to password, right? Similar to password. So this is what needs to be shared for you to be able to break, all right, that's, encryption. For example, I can say A, B, C, D, E, all right. The key may be, all right, so A, B, C, D, E, F, G, H. So the key may be 1, 2, 3, 4, 5, 6. All right. 7, A, B, C, D, E, F, G, H, 8. All right. And let's say I, and this is 9, right? All right, so let's assume I sent a message out to the group and I say uh, 9, all right, A, B, C, D, E, A, B, C, D, E, F. All right, so that's 6. All right, so if I send 96 out, all right, I just type 96 in the chat box, right? To any other person looking at it, this is what they call encryption by substitution. No, it's just by substitution. It's very easy to break actually with these days with computers and the rest, all right? So, but for at the manual level, it's not, it looks strange, all right? So 96, if I said that 96, all right, you need to know the key that A is 1, B is 2, all right, C is 3, D is 5, D is 4, all right, E is 6, all right, and so on, like that, for you to be able to know that, okay, 96 actually can be what I'm actually saying here, all right, is if. All right, so to anybody that does not know the key, all right, he's just seeing 96, all right, but actually what I'm saying, sending out is if. So I can send a very secret coded message, all right, using the entire alphabet A to Z, they map it to numbers. And of course, it might not be as easy as 1, 2, 3, 4. It can be in reverse. All right, sometimes you make it more difficult like that. I can reverse it. So instead of 1, I can start with maybe 27 and take it backwards, and that make it more complex. So if I send that one out, it will be very, 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 even as simple as it is now in computer age, all right? Unless you know there's a relationship between the alphabet and the numerals, then it's going to be difficult. So even breaking it, I remember I was reading about World War II. One of the coders, the people in charge of breaking codes for the US, for US. One of them was, oh, they have to, he was going crazy. Actually, they have to relieve him, send him out of the project, right? Because he was just, if he sleeps like this, he will just be seeing a dog, and with codes, they wrote code all over the body of the dog. Every time he sleeps, you see a dog, all right, with codes written all over him. So they realize that this guy is about to cross to the other side. So that's how they just have to train. So it's a very strenuous thing, especially all right, where the algorithm is very complex. All right. So we need that in a very, very, very strong algorithm and keys. All right. So the key is like a password. So once you don't know the key, forget it. All right. Then also I need to mention that the longer the key, the more difficult it is to break that encryption. That's what they call crypt analysis. Crypt analysis is the process of breaking an encryption algorithm. All right, most of the time illegally. But if just like in password, the longer the length of the password, all right, the more secure the password. We know that. So the same thing in encryption. The longer the encryption key, the more difficult it is to break the encryption. But note, it's secure, but it also means it will slow down the encryption process and the decryption process. You will need more overhead to process a longer key than a shorter key. Please take note. This exam is they like checking pros and cons, pros and cons, pros and cons. All right. So you need a very lengthy key, encryption key. All right. But take note that it's going to also reduce it's going to increase your overhead and slow the encryption process down. All right. So it's 11:33. Let's take a short break. All right, let's take a short break till 12 o'clock. All right, so let's take a short break till 12 o'clock. Then we resume by 12. So see you by 12. Please, your questions, prepare your questions in case you have questions so that we can look at them together. So when we come back by 12, we look at the different types of encryption that we have. Thank you. Okay, well, welcome back. We'll stop at types of encryption. So there are basically three types of encryption, basically three types of encryption. All right, so we have three types of encryption. We have symmetric key encryption. It's also called private key, right? It's also called private key encryption. Okay, so we have symmetric key encryption. It's also called private key encryption. Okay. So in symmetric key encryption or private key encryption, all right, the key used to encrypt, all right, is also used to decrypt, also used to decrypt. So it's the same thing, all right? The key used for encryption is also the same used to encrypt. So which means the challenge is if I encrypt a message and send it to you, I also need to send the key to you. All right, because the key I use to encrypt is the same key you use. All right, we all do PDF encryption, right? We all do password, we password PDF file, password Microsoft file. All right, you notice that the key you use to encrypt that Microsoft file, you have to get it across to the other party. All right, the challenge here is, all right, so pro advantage of this, all right, is that it's fast, all right, fast encryption, fast decryption. All right, the con is that, all right, security of the key is a challenge, right? In the course of sending the key across, it could be hijacked. You send it by email, you send it by phone, the third party can see it. That is the challenge with symmetric key encryption. A good examples of this, you have DES, all right, data encryption standard, you have triple DES, all right, triple DES. You have AES, Advanced Encryption Standard. This is the one that is most secure. Advanced Encryption Standard is deemed to be very, very secure. All right, the most secure out of all of them. Then, so you have asymmetric, right? Asymmetric encryption is also called public key encryption, all right? Asymmetric. Now, the challenge in symmetric is that how do we get the key across? Right? How do we get the key across? All right, of they call it the session key, security of the session key. That is the key that we use to encrypt. How do we get it to the other party safely? Now, so in asymmetric, some guys came up with the idea to solve that problem. It's okay, no problem. The sender, right? This is very important. Please take note of this. It's very confusing. So you have a sender, you have a receiver, right? All right. So the sender will have a private key. The sender will also have his or her own public key, as I know. Private key, public key. The receiver too will have his own sets, all right? All right, the receiver too will have his own set of private key and public key. Now take notes. Private key of the sender is known only to the sender. Only to the sender. Only by the sender. That's why it's private, right? So you don't share it. The same thing, private key of the receiver. These are very important. All right. Private key of the receiver is known only to the same receiver. They don't share it. Now, these are very, very fundamental. Very fundamental. All right. So private key of the sender is known only by the sender. All right. Private key of the receiver is known only by the receiver. Okay. Then a message encrypted with the private key of the sender can only be decrypted with the public key of the sender and vice versa. See, there's a relationship. So once you have encrypted the message with the private key of the sender, that message can only be decrypted with the public key of the sender and vice versa. So the same way, a message encrypted with the private key of the receiver, the same way, right? Receiver can only be decrypted with the public key of the receiver and vice versa. This is how it works. Now, so this information is very key for us to understand encryption. Private key of the sender is known only to the sender. All right, private key of the receiver is known only to the receiver. All right. Message encrypted with the private key of the sender can only be decrypted with the public key of the sender and vice versa. Message encrypted with the private key of the receiver can only be decrypted with the public key of the receiver and vice versa. So that leads us to objectives of encryption, right? Objectives of encryption. Now, there are 4 objectives of encryption, even though one is most popularly known. The most popularly known is confidentiality. We all know this, right? The reason we use encryption is because we want to make an information confidential. Now, in asymmetric encryption, how do you achieve confidentiality? All right, encrypt the message with the public key of the receiver. Okay, I forgot something. All right. So the public key of both parties can be shared. Right? Can be shared securely. All right. So you can find a secure way of sharing the public key. But even if it is compromised, the damage is not as serious as in private key cryptography. You will see why shortly. So you have Tom want to send a message to Jerry, all right, and he wants only Jerry to be able to read the message, so that in case that message falls into the hand of somebody else, all right, that person cannot read it. So what does Tom do? He will encrypt the message with the public key of Jerry. What does that mean? That message can only be decrypted with the private key of Jerry. Remember, the message encrypted with the private key of the receiver can only be decrypted with the public key of the receiver, and vice versa. So if I encrypt a message with the public key of the receiver, all right, it means only the private key. So implication of this. Please, if it's not clear, I beg, let me know. This is where it gets confusing sometimes. All right. So implication is that the message can only be decrypted, all right, with the private key of the receiver. Don't forget that the private key of the receiver is personal, it's not shared. So that means we have locked that message to that receiver. So that's how we achieve confidentiality, all right, with encryption. All right, so this is the number 1 objective, publicly known confidentiality. But we can do more, all right, with encryption. We can also do authentication with encryption. All right, so authentication, you want to verify the sender. So authentication means verify the sender. So how do you verify sender? Using encryption, all right? You encrypt the message, all right, with the private key of the sender. So it's all like in analog letter writing, right? If you send me a letter and you didn't sign it, and on paper, how do I know it's you? Of course, I will not believe it's you, right? But the moment you sign it, all right, I will say yes, this message is from so and so, all right, because I can see name and signature and date. So when we see the private, and the private key of the sender is personal to the sender. So once we see the message, all right, encrypted with the private key of the sender, all right, automatically we are sure that that message is from the sender. How do we validate that is private key of the sender, you know the public key of the sender, it has been shared. All right. So if you decrypt the message with the public key of the sender and the letter, all right, the message can be read, definitely you know there is a match. So before you can decrypt a message encrypted with the private key of the sender, you need to get the public key of the sender, which must have been earlier shared with you. So once you can decrypt that message with the public key of the sender, all right, so that you know that that person cannot deny. Now, that inability to deny, all right, is now leads us to number 3, which we call non-reputation. Please, this is important. Non-reputation. It means that you have already sent a message, you can't deny you're not the one that sent the message. How do you achieve non-reputation? The same way you achieve authentication is the same way you achieve non-reputation. And keep that message with the private key of the sender. Good luck. All right, because I have your public key, all right, and I got a message from you, and the message is encrypted. I said this is XYZ private key, and I have this our public key, and I use our public key to decrypt the message. I was able to read it. So how will you now say you're not the one, unless you don't want to say that your private key was compromised, and that's not an excuse. That's your business. All right. So once a message is decrypted with the public key of the sender, automatically that message is from the sender. So that sender cannot deny again that he or she was not the one. So with asymmetric encryption or public key cryptography, all right. So we have symmetric, all right, as a type of encryption. Number one. All right, number one type of encryption. So symmetric or private key. The session key used to encrypt is the same session key used to decrypt. It's fast, right? But the challenge is how do I get the key across in such a way that there won't be, it won't be compromised, right? Then they came up with asymmetric or public key cryptography. All right, cryptography is the same thing as encryption. So this time around, the sender is required to have each party will have a private key, public key. All right. Then you understand the rules. Private key of everybody should keep your private key private. All right. Should not be shared. All right. But a message encrypted with the public key of a sender or a receiver can be decrypted only by the public private key of the sender or receiver, or vice versa. That is the general rule. All right. So in every encryption, all right, 2 keys are always in operation, not one. All right. So the public key will have been shared, maybe to a server that we all know the link. All right. We all know the IP address. We can all drop our public key there. So objective of encryption confidentiality. All right. To achieve that, encrypt the message with the public key of the receiver. All right. Knowing that only the private key of the receiver can decrypt it, and the private key of the receiver is known only to the receiver. So that makes it confidential. Authentication. Want to verify that the sender is actually the sender. All right. So what do? The sender must encrypt the message with his or private key. All right. Then the receiver, having the public key of the sender, we try to use the public key of the sender to decrypt it. If the decryption is successful, automatically we have verified that it was the sender. The third objective is non-repudiation. What do we do? Non-repudiation means if you send a message, all right, you can't deny you are not the one that sent it. All right. How do we achieve that? The sender sends the message, all right, encrypt the message with the private key of the sender. Once the receiver can decrypt that message with the public key of the receiver, of the sender, it's over. All right, you can't deny it again. So you can look for another excuse to say my private key was hacked. You can say something, but you cannot say you're not the one. All right. So that's the third. The fourth objective of encryption is the fourth objective of encryption. Number 4. All right, so we have confidentiality, we have authentication, we have non-repudiation. The fourth one is integrity. Integrity here is a bit different from what we've been talking about since. Integrity means It's not prevention. You can't stop encryption will not stop a message from being altered. All right, it's basically to detect, right? So here is more of detection, all right, if unauthorized change has occurred. All right, so for that, we use the third type of encryption. All right, so here we have, let's call this one A, right? First type of encryption, symmetric key. Let's call this one B. Second type of encryption, asymmetric or public key. All right, a good example is DSA, RSA rather, RSA. All right, it's an encryption technology. They named it after the guy that came up, the three guys that developed it, Rivest, Shamir, and Admiral. Rivest, Shamir, and Admiral. Those are the three guys that came up with it. So they name it after their surname. All right. So the third type of encryption, all right. So I said the first objective of encryption, confidentiality, all right, authentication, all right, non-repudiation, all right, applies to asymmetric, even though confidentiality too applies to symmetric, obviously, firstly. All right. But when it comes to the fourth type, integrity, we'll be looking at the third type of encryption, C, all right, which is hash, they call it hash function. Hash function algorithm. Now, how does this hash function algorithm, how does it work? So a example is MD2, MD2, MD5. That MD is message digest, And there's also one called SHA, secure hash algorithm, All right, so how does hash function algorithm work? It calculates what we call hash. All right, it's also called digest. It calculates hash or digest. Now, what is hash? All right, let's say, assume I say, okay, there's a book called Akin Goes to School, right? Akin Goes to School. So this Akin Goes to School, we can pass it to a secure hash algorithm, right? Maybe SHA, to create a digital summary. So this is actually like a digital summary, summarize it. Digital summary of that message. So let's say our kid goes to school. Let's assume that the digital summary is this. It's always, something nonsensical. It's not something that is reasonable. The idea is you can't really understand it. Now, how many characters is there? 1, 2, 3, 4, 5, 6, 7. All right, so let's do 8 character. So this is the 8 character. It's always fixed length. Each algorithm, all right, each hash function has its own fixed length. Could be 15. All right, no matter the number of the size of the message, it will reduce it into a fixed length, maybe 20, maybe 100 character, maybe 10. All right, so let's assume this one is using 8 fixed length. All right, so this is it. So Akin goes to school. This is the hash. All right, but so let's assume I want to send this message to you now. All right, so I will send this message. Akin goes to school. I will also send the hash to you. All right. The idea is you too. You also have the SHA algorithm. So when you get my message, you will now recalculate the hash. If you now get this exactly, so sender sends this. Okay, so this is from the sender. Then the receiver also gets this. You compare, it's the same thing. That means the message has not been tampered with. But let's assume before the message gets to you, Somehow, somebody was able to change it to another book. Of course, there's another book called Easy Go to School, right? There's another book called Easy Go to School. But this is, I actually send you and say, okay, the book you should read is Akin Goes to School. All right. And I send the ash. Now, somebody was able to tamper and change Akin to Easy. All right. And say, no, this is not the book you should read. Read Easy Goes to School. Now, when you get this Easy Goes to School, you will now run, of course, you got this. You got this. All right. You got this digest. Now, you will now convert this again to digital summary. When you run the hash algorithm on as it goes to school, you will not get this. All right, maybe you get something like this: number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. You may get something like this. So automatically, what is this telling you? All right, so you compare it in two digests. All right, the same fixed length, but different. Automatically, you know that that message has been altered. All right, so that is what they use, hash function to do. I'm sure you also will have realized that it also has so many applications. They use also in software, all right? You want to download the genuine software. Some of those software websites, they drop the hash function, the digest of the original software. I'm sure you will have noticed on their website. So that when if you download from anywhere, you can also get the digest and compare with the original. If it's not the same, you have downloaded fake software. So you can see one wonderful application. Another application of this is in password. I'm sure you will have noticed. Well, we may have known, all right, that password is not stored the way we write it. All right, so let's assume my password is John Wick. John Wick. All right. At 76. Now, this is a strong password. At least, generally, the length, all right, is more than 10. All right, it has capital letter, it has small letter, it has numerals, it has special character. So, generally, this is a strong password. John Wick at 76. Now, a very good password system cannot or should not store my password like this, right? It should use a hash function algorithm to convert this John Wick at 76 to a nonce, to a digest. So if you look at John Wick at 76, if you look at the password file, you will not see this John Wick at 76. You will see something like this. All right, maybe Z, all right, so this 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 8. All right. So you can see, even though this Akin goes to school, all right, the digest has eight character. All right, Eze goes to school, the digest has 8 characters. All right, John Wick has 76, even though it's smaller, it is the same length. All right, it's going to be the same length. All of them will have the same length, basically. So something like this. So John Wick has 76 is stored in the password file as this. The idea is, and another thing is, need to take note here is that hash function is irreversible, right? So you can't go from this to this. You can't go from this, you can't reverse from this to this, you can't reverse from this to this. So the idea is, even if this password file is hacked, all right, there is no way the hacker can be able to reverse and say, okay, this means John Wick at 76. It's not possible. All right. There are longer ways where it is other things that can be done to, but it's like a shortcut. But it's not even a shortcut, it's a long cut. They call this rainbow table. But let's leave that one for now. All right. But it's very arduous. It's very arduous. almost impossible. So the idea is we can't reverse. So we stop, but even in Nigeria, even in financial system, I've seen systems that passwords are not encrypted, right? Not encrypted. So in password management is even wrong. For you to even use, for you to use what is it called? Asymmetric is even wrong. All right, no talk of symmetric because both of them are reversible. All right, symmetric is reversible. You can convert the ciphertext back to plain text. Asymmetric, you can convert the ciphertext back to, plain text. But when it comes to hash function, it is impossible. You can't convert the ciphertext back to plain text. That's why it is being used in password. So whatever you type, so when you are signing on a system, the system is not actually checking this, whether it is right or wrong. This is what the system is checking, the hash of whatever you are typing. In a good environment, or in a good secure environment, like I've said, it's not all security implementers remembers, or maybe it is deliberate because, for example, the banking environment where I see that the passwords are not encrypted, I believe the environment is too mature for them not to know. So somebody in IT deliberately decided not to encrypt the password. That is my own conclusion. I may be wrong, but me, I believe that information in IT, banking, IT environment, for them not to encrypt password, all right, then definitely for me, all right, I believe it's deliberate. Somebody is playing with people's money in that bank. So these are the different type of encryption that we have. So digest hash function especially has a lot of application in information security. So I try to use this method so that it will be simplified for us. We can easily get it. It will be very confusing. All right. So you can see symmetric. Like I said, the same key is used to encrypt. The same key is used to decrypt. All right. So example, the data encryption standard, triple S. All right. You also have quantum cryptography. All right. Quantum cryptography. They are working on this. All right. Where they use light photons for encryption. Right. I don't know how far they've gone. All right. With this, we use light photons for encryption. All right. Then you have asymmetric, like I said, public key cryptography. A good example is RSA. I mentioned RSA, Rivers, Shamiro, and Ma. All right, those are the guys that came up with it. They used their name. Then you also have elliptical curve cryptography. Now, this one we interact with this almost on daily basis. This is what they use to do encryption on phones. Like when you get your WhatsApp, you see that your WhatsApp is encrypted end to end. So elliptical curve cryptography is what you use to do encryption on small mobile devices that have limited computing power. All right, limited computing power. So they use elliptical curve. Please take note, it's examinable. All right, when you want to do encryption on it or a small device that have limited computing power, you use elliptical curve cryptography. All right, where is that? Okay, so you can see it here. All right. It's used to create faster, smaller, and more efficient cryptographic keys. All right. So EFCC, I say EFCC. ECC helps to establish equivalent security with lower computing power and battery resources. It's becoming widely used for mobile applications. So if you want to encrypt on a device that has small, limited computing power, you use elliptical curve cryptography. Please don't forget. All right, I've explained all these: authentication or reputation, confidentiality, integrity. So for integrity, we use hash function. So you can see a very good example, Fox. All right, this is the digest. All right, red fox jumps over the bulldog. This is the digest. All right, now somebody changed the V to U now. All right, so you can see if you look at it carefully, they've changed the V to U, OA, instead of over. All right, now the digest changed, the hash function changed. All right, somebody even changed, the arrangement of the over completely, the digest changed again. Somebody removed the V completely, the digest changed, you can see. So You can always compare the sender, the receiver can always compare the digest he or she gets with the digest that he or she computed. And if they are the same, fine. The message is the same. If they are not, if the digests are not the same, obviously that means that digest has been tampered with. Okay, so those are the 4 objectives of cryptography. Please don't forget confidentiality, integrity, non-repudiation, authentication. All right, CINA. All right, CINA abbreviation. All right, then we have encryption protocols. Protocols that they normally use to encrypt in a network environment like IPsec. So we talk about packets the other time. Packets. Another name for packet is IP, right? Talking about packets the other time. Fine. Here, right? So it's actually IP packets. The full name is actually IP packets. That's the real name. IP is internet protocol packets. Now, you can see it's made up of either payload footer. There's nothing around security on this. The component is not secure at all. It's those IP packets normally doesn't have security. So if you are moving very sensitive information, you have to be very careful. So you introduce IPsec. IPsec is IP security, Internet Protocol Security, all right, as a protocol to secure your vulnerable internet IP packets. Get, all right. So we have point-to-point tunneling protocol, all right. So you already know what point-to-point mean. I was saying like you have a head office at the branch, one point to the other. So they use point-to-point wide area network technology. So they also created an encryption for when you have 2 points like that. You are not transmitting beyond 2 points. All right. There's also an encryption protocol, all right, when you are moving from one point, just from one point to the other and vice versa. All right. So you have point-to-point tunneling protocol. You have layer 2 tunneling protocol. Another thing I need to say about these tunneling protocols, all right, is that those are the protocols they use in VPN, virtual private network. Because actually, how does VPN work? How does VPN work? VPN works over the internet. All right, VPN works over, and we all know that internet is not secure. All right, everybody is present on the internet. All right, so you don't know who is who. All right, so you have Lagos head office. All right, then you have somebody, maybe in maybe somebody in where now? Let's say maybe Kafacha, right? So there is somebody that went to do a job in Kafacha. Fine. Now, this person requires remote, all right, control. I mean, remote login from Kafancha to Lagos. All right. So what VPN simply does is, so you have internet cloud. All right. So this is internet cloud. All right, linking them together. We could have just gone through the internet, all right, and connect Kafancha and Lagos, but we know that is not safe. All right, so what VPN does, VPN now creates a tunnel through the internet cloud. So that tunnel is still through the internet. The tunnel passes through the cloud, link Lagos and Kafancha, such that if you don't have access, you can't know what is in that tunnel. Don't know what is going on. The tunnel, so you have protocols that create like a tunnel. It creates a tunnel. All right, through the internet. And that's what made VPN a little bit, relatively affordable, because it leverages on the internet, which is relatively cheap now. Relatively affordable now. So it creates a tunnel link Lagos and Kafacha together. So what goes on inside that tunnel is, the rest of the internet world is cut off from it. All right, that is what we mean. That is what tunneling protocols does. All right, but basically they are built up. They are made up of encryption technologies. Then, of course, we have the most popular one, all right, SSL, all right, the most popular one, SSL. So you'll have seen it. Most websites that we use for payments, all right, they use this SSL to be able to encrypt. So whatever we are typing, all right, is encrypted, all right. Primary account number, CVV, PIN, card details, and so on. We want to ensure that they are protected. So we can use SSL. It's also an encryption technology. All right, TLS has been developed to replace SSL, but that has not happened. I don't know why. All right. So transport layer security was also an advanced form of secure socket layer meant to replace SSL, but SSL has been stubborn, that's refused to leave the scene. So I think both of them are being used concurrently for now. Then we have digital signature. So digital signature is just like our normal signature, right? You write a letter, you sign it, all right? So the same way you have digital signature, which is more or less to say, okay, this is my digital, I signed this particular message, all right? So when you say sign, you know that from the private key we have talked about, you know that it's going to be linked to private key. So what we do is that number one, you create a digest. Okay, so you create a digest of a message or the hash of a message. Then you now sign the hash. So you encrypt the hash. Encrypt the hash with the private key of the sender, with the private key. Okay, so you create a digest of a message, all right? You know how to create the digest of the message. Now that means you're going to use an encryption hash function algorithm, SHA-1, SHA-2, SHA-212, all right, MD2. Well, there are many of them in the market. So create the hash of the message or digest of the message, encrypt that hash with the private key of the sender. All right, so that way you are able to tie, so you are able to achieve one. So what do you achieve with digital signature? Number one, since hash is involved, all right, that means we can know whether the message has been changed. All right, so that means we can use digital signature to achieve integrity. Don't forget. Number two, all right, since the private key of the sender is involved, all right, that means we can use it to achieve authentication. We can use to know whether the message is coming from the sender actually or not. And since whatever achieve authentication will also help you to achieve non-repudiation, since the private key of the sender is involved. So with digital signature, you can achieve integrity, you can achieve authentication, you can achieve non-repudiation. What is the application of digital signature is commonly used in email application. I'm sure we must have been seeing it on email platforms. So you can see this email. Look at Outlook, right? So most of these things that we are talking about is done behind the scene. We don't even know, all right, that is happening. So you can see this particular email app. You just check. So add the digital signature to all messages I sent. All right. So once you check that, so the system creates a digital message, a digital signature for you as an added security. You can just use this email to another platform, add digital signature to outgoing messages. So you check it. So you can see it under email security. All right. So the idea is that people can verify that a message is actually coming from you. All right. You know that this famous Yahoo boy that's in America now, Hush Puppy, is basically email breach, email attacks they were using. So they will fake the email coming from the CFO. All right, the CFO will send a mail, or the CEO will give an instruction to the CFO, they will fake it, and the CFO too, they will fake his instruction to another person like that. And there were no means for those people to detect that the message is not coming from this individual, and they will transfer the money as instructed by the Yahoo boys. All right, so it's very important. So email security, we can use digital signature as an extra layer of security so that people can confirm, the receiver can confirm that indeed the message is actually coming from you. All right, please take notes of what we can do, what we can use digital security to achieve: integrity, authentication, and reputation. This is where most of the questions I've seen on digital signature is where most of them are focused on. Don't forget. All right. We also have what we call digital envelope. So what do we mean by digital envelope? Now, we've already said it that private key cryptography, all right, is slow. I mean, it's fast, all right, but insecure, all right, it's insecure, all right, because you have to move, all right, the session key up and down. Then we have the public key cryptography, is secure, all right. I think I forgot to mention, it's slow. All right, it's lower compared to private key cryptography, but it's more secure. All right, so these are the two disadvantages. All right, so but these are, so the advantage is there. This is fast, right? But insecure. This is secure but slow. So what we want to do is that we want to cancel the disadvantages and retain only the advantage. So we are going to combine the two of them, combine the strength of two of them. So let's assume we have a bulk message to encrypt. All right, if we encrypt with the private key cryptography, it's going to be fast for bulk messages, but security challenge is there. But if you encrypt with public cryptography for bulk message, it's going to be secure, but man, it's going to be slow. So what do we do? So we start like this. Encrypt the message, all right, with private key cryptography. So we start like that. Digital envelope. So the bulk message you want to encrypt, all right, use private key, no problem. So which means you are going to use a session key, right? So there will be a session key. So the session key is the key that you use to encrypt, all right, which you will send. The problem before, all right, is how do I get that session key to you? That's the real problem before. Now, this time around now, how that will be corrected is now we will now encrypt the session key. So now encrypt the session key, all right, using public key cryptography. We will now use public key cryptography. For example, e.g., encrypt the session key with the public key of the receiver. So what this means is that we have a session key. We encrypt with the private key cryptography. So the whole encryption is going to be fast. All right. But the session key now, but remember the session key is very small compared to the whole documents or the whole message. The session key will always just like a password. So it's just small. So that small session key, we can encrypt it with the public key of the receiver using public key cryptography. Because it's small, all right, it will still be relatively fast compared to using public key cryptography to encrypt the whole message. All right, so this one too will be relatively fast. All right, so it will be fast and secure. Well, let me put relatively. So it's only the session key we are encrypting with public key cryptography. So compared to using public key cryptography to encrypt the whole message, so it's relatively fast. and now it is secure. Because now, for example, now if we encrypt the session key with the public key of the receiver, it means only the private key of the receiver can decrypt it, and the private key of the receiver is known only to the receiver. So we have achieved security. So by using, so this is what is called digital envelope. By combining the two systems, all right, two encryption systems, we have knocked off the disadvantages of the two of them, and we have harnessed the advantages of the two of them. Very brilliant. Somebody came up. So people are always thinking, all right. People are always thinking. So this is an innovation that somebody came up with, especially when you have bulk messages. You have bulk messages to encrypt. Okay. So that's exactly what I repeated there. Encrypt the message with symmetric key encryption is fast. Encrypt the session key, which is now very small, with asymmetric encryption, right? With, for example, with the public key of the receiver, send the encrypted message and the encrypted session key. So you have to send the encrypted message. You have to send the encrypted message now to the person, and send the encrypted session key also to the receiver. All right. So even if the session key falls into wrong hands, let's assume that the session key falls into wrong hand, it's encrypted. Only the private key of the receiver can decrypt it. So it will still be useless to that person. And if you cannot decrypt the session key, you cannot decrypt the message. All right. So you have achieved security, you have also achieved efficiency. That is the concept behind digital envelope. Then we have what is called public key infrastructure. All right. I remember there was a time I wanted to do a transaction online, and I went to the organization and I typed the organization name, and I saw like hundreds of websites, and I was a little bit scared. All right, if I don't know which of the website is correct. All right, so because I wasn't sure, I decided to trace that organization to their office. I actually paid 30,000 naira extra. It's cheaper. It's cheaper to go to for the online. It's cheaper to book online, right? But for you to now order, right, to the office, you pay like 30K extra. But I did it, right? Why? Because I was not sure. That is what public infrastructure is trying to address, to be able to build confidence in online payment system. Right? So you don't know the owner of the website, right? And it could be, we've had cases of people registering on fake jump sites, fake WIRE sites, So all manner, people are creating mimic, creating dummy websites to mimic the original website. So if you are not careful, all right, you're going to do transactions on a false website, or you are going to provide the information on a false website. So that is why, you have what is called public key cryptography, public key infrastructure, so that both parties, the seller and the buyer, can, have peace of mind. So we have what they call, certificate authority. Certificate authorities. All right. The job of these certificate authorities is more or less to provide confidence, all right, to users online, internet users, that look, this website is genuine, is okay. All right. So one of them is VeriSign. I'm sure we have all seen these guys online. All right. If you have, maybe you have not noticed, all right, but if you watch out for them now, you will see them. I'm sure virtually all of us will have seen it. All right. Then you go to some website, you will see a padlock at the bottom right. I think it's right, right, bottom right corner. You will see this verified by VeriSign. I'm sure we can all recollect. You must have seen this somewhere. Verified by VeriSign. What does that mean? When you see a padlock by the side, they are telling you that this website is who it says it is. What it offers is genuine. All right, we are guaranteeing you that you can do whatever you want to do on this website. It is safe. Is that not wonderful? So you have VeriSign, you have thoughts. I hope I got the pronunciation correctly. all right, your thoughts. You have Komodo, all right? Komodo. Even Microsoft does it, all right? Even Microsoft, all right, also do certificate authority, all right? So you have Komodo and so on and so on. So their job basically is to provide confidence, all right? And if you have noticed, virtually most of these websites have, what they do is that they issue digital certificates. They issue digital certificates to websites. So the idea of the digital certificate is that that we have investigated this website. They are who they say, yeah, physical, we have confirmed their physical address, they have confirmed their management. All right. So once they are sure, they issue digital certificate. Now, the investigative aspects of this before they can issue digital certificate, of course, they have to they have to verify the background check. Now, that background check work may be too if they have too many things, too many job on their hand, they may not be able to physically go and check and things like that. So they may delegate some of those checks to what is called registration authorities, RA. So the registration authority performs administrative background checks on behalf of the certificate authority, but they don't issue digital certificate. They will not. They only make recommendation. We have checked though. But everything they fill in the form is accurate. Confirm their head office, confirm their management, confirm their certifications, accreditations, confirm their products, they are not lying, they are not, So based on that, the certificate authority can issue the digital certificate. So basically, the certificate authority is a trusted entity that issue electronic document. I've talked about the registration authority. They are the one that verify, right, the certificates, that they verify the user on behalf of the certificate authority, but they don't issue certificates. Please don't forget. Then basically, once the certificate authority is convinced that the web, most of the time is seller organization, right? So they can now issue the user certificate, which is an electronic passport. All right. I say, yes, we know these guys. All right. So the certificate, you can see an example of a certificate for HSBC. So you can see VeriSign, right? So this is issued by VeriSign, that is certificate authority. It normally has validity. I'm sure you will have noticed sometime when you go to yahoo.com, all right, to tell you that the certificate has expired. Yes, it does expire. It means you are meant to renew. You can see this one, validity is between 21st May 2008 to 22nd May 2010. So if they don't renew after 22nd May, it will expire. That does not mean they are not in any website. It just means that the certificate has expired. All right. So a lot of time when I see that flag, and I'm very sure I'm on yahoo.com, I will still go ahead and browse. But it will tell you that you're your own, all right, because that certificate has expired. Then we have what we call a certification practice statement. What is that? It's simply to tell you the user, the rules, the policies that the certificate authority uses in issuing certificates, publishing, archiving, revoking certificates sometimes. All right, they can revoke it if they discover that your business have changed along the line, which is possible. They can revoke their certificate because it's their name. All right, and I've talked about renewal. You're supposed to renew, all right, at the expiry of the validity, all right, of uh, the certification. So that's that about key what is it called now? Public infrastructure. It's basically, all right, the system that has been put in place to improve, all right, the confidence that people that we have on the, when we go online to shop. All right. Do we have questions? Questions? Question on encryption, public infrastructure, and so on. we've had only one question since. So like I said, if people are not asking questions, it's only either whether they are getting it or they are not. So I hope it's the former. Or you are getting it now while there's no question. Okay. So it's 1 p.m. It's 1 p.m. now. So let's go for our lunch break. All right. Online training could be demanding, so it's good we have all these breaks so that we can relax and refresh ourselves. So let's take a 1 hour break. Then we come back by 2. We're almost through with domain 5. All right. Come back by 2 o'clock. Then we can do maybe 1 hour, 1 hour, 30 minutes, and we can round up 5. All right. So see you by 2.